There's some more measurement ideas we need to think about. This time we're going to be measuring the dimensions of this glue stick, and I'd like to find the volume of the glue stick. In order to find the volume of the glue stick, I'm going to need to find a measurement for the length, and also I'm going to need to find the value of the cross-sectional area of the end. Now, as you know from maths, the going to be cross-sectional area of the edge, which is pi r squared, times by h for the length of the cylinder. So let's take some measurements for that then. First of all, our h for the length of the cylinder. So lining that up nicely, the length of the cylinder is 11.4 centimetres. So I can say h is 11.4 centimetres. What about the radius? Well, it's tricky to measure the radius directly, but I can measure the diameter. If I line that up, you can see my diameter is 3.0 centimetres. Diameter is 3.0 centimetres. So the radius then is 1.5 centimetres. Let's put that into the formula. Volume is pi r squared h. So we've got pi times 1.5 squared times 11.4. I can't do that in my head, so let's grab a calculator for that. So here we go then. We've got pi times 1.5 squared times 11.4. I'm going to express that as a decimal. And we've got 80.58185156. But how many of those decimal places is it reasonable to write down for your answer? Well, in physics, how we express the significant figures of our answer is really important because it tells us a lot about the resolution of the readings we had in the first place. Look at these readings. I've got a resolution of 0.1 centimetres for the height. I've got a resolution of 0.1 centimetres for the radius. Here I've got three significant figures. Here for my diameter, I've got two significant figures. This 0 is significant because it's telling the reader that it's 3.0, not 3.1 or 3.2. So for my collected data, and these two are my collected data, the lowest number of significant figures is two significant figures for diameter. So that's the number of significant figures that we would use for our answer. So although we've got all of these numbers on our calculator, the best way to record our answer is 81 cubic centimetres. Let's think also about some of the things that could have gone wrong with the measurement. We talked before about random and systematic errors. Here's another thing that can go wrong. Here's my glue stick and here's my scale. And when I was making my measurements, I had my scale really close against the glue stick. But if I was trying to take my measurement with the scale offset from the glue stick, it becomes really difficult to take a measurement. Also, I might be viewing my glue stick from different angles. And you can see that if I was viewing the glue stick from different angles, I'd get different measurements every time. This kind of error, where typically you've got a scale that's not right up against the thing that you're measuring, and you're viewing it from different angles, This is called a parallax error. A parallax error can be random if your head is moving around all over the place, or it can be systematic if you're always viewing from an angle that's not straight on. But the best way to take a measurement is to have the scale right up against the thing that you're measuring and be viewing straight on to that measurement. So we've looked then at the appropriate number of significant figures for an answer, and we've looked at the fact that the best number of significant figures for the answer is the smallest number of significant figures that's represented in the data. And we've also looked at how parallax error could affect our measurement.